Hello everyone, welcome to another C++ template metaprogramming video, and in this video I'm going to show you how to implement your own std is same. So std is same is a struct that contains a boolean attribute, and you can query it by typing : value, and then it uses the correct specialization whether it is true or false. So in this case it's going to be false, but the question is, how do we do it? How do we implement our own std is same? Well, let me first just check that this indeed evaluates to false. So std is same requires two template parameters, namely a first one and the second one. And conventionally I think this is called t1 or t2, but this is just boilerplate, or well, it's not boilerplate per se, but it's implementation details, so doesn't really matter what you call it, T1 or T2 or whatever. So yeah, it requires two template parameters, and as you can see I've passed two types in it, and the left one is the integer, as you can see, and the right one is float. So obviously integer and float are not the same, so this is gonna print false. And let me just build so you can see that is the case. False, right? No, nothing strange there. And well, if you change this to int, then obviously it's gonna print true, because int and int are the same. Right, true. But you have to be, well, sort of careful, because while this may sort of seem the same, the types aren't exactly the same. I mean, yes, they're both integers, but one is an regular int and the right is a integer reference. So int and int ref are not the same, and I will show you that in a moment. Yes, false. So obviously int and integer reference are not the same. And if left or right is convertible to each other, then that also gives false, because they're not the same. So if I were to pass an unsigned integer here, then this would also evaluate to false, because int and unsigned int are not the same. They may contain the same values, sort of, but they are not the same type, right? So we're gonna write our own std is same, and as I told you earlier, it contains two template parameters. So we're just gonna write a struct that contains a t1 and t2, and so we're not 100% sure whether t1 and t2 are the same. So in this specific case, we're gonna create an attribute value called value, and we're gonna set it to false, because we're not 100% sure t1 and t2 may be the same or are the same. They might be, but we're not 100% sure. So we need to figure out a way how we can be 100% sure. But in this specific case, we're not 100% sure. So we're just gonna write struct is same, right? So again, t1 and t2 may be the same, but they don't have to be, right? So we're gonna write static const expr boolean value equals false, because again, we're not 100% sure that t1 and t2 are the same. So now let us think, right? How can we find, or how can we ensure that, how can we find out that t1 and t2 are the same? So in previous videos I have shown you the essence of specialization, and well, you can partial specialize struct is same. So you do that by saying template again, and this time it's not going to be empty, but it contains either t1 or t2, doesn't really matter in this case. So we're going to say class t1, right? And so we have a type here, say let's say integer, right? So we're gonna say struct is same again. So this is a partial specialization, and as part of partial specialization, we need to insert the template parameters here. So we're gonna partial specialize is same, and we're gonna pass two of the same types. Now how do we do that? Well, that's quite easy. We're just gonna say T1 and T1. So we only have one type here, so we know for sure that these two T's are the same. Of course, they refer to the same T. So if T1 is an int, then every T1 is replaced by int. So this is int and this is int. So that's not really rocket science, right? So here we know for 100% sure that T1 is in fact the same type. So we can do a curly brace, open, and put a dot semicolon right there. And we're gonna say static const expr bool value equals true. And that is because, well, T1, everywhere T1 is referenced, is the same. So we know that T1 is the same. Everywhere where T1 is referenced is the same, right? So let me just test this real quick. So we're gonna call int and unsigned int, right? So the compiler is gonna check, all right, you have two overloads. You have one with T1 and one with T2, and they don't have to be the same type. And you have one where T1 has to be the same type, right? So it's gonna check whether or which overload, so to speak, is the most suitable. Well, in this case, it's gonna choose this one over this one, because it cannot instantiate a struct of the same T1s, because everywhere where T1 is referenced, it should be the same type, right? And int and unsigned int are not the same type. So let me just print that out. And of course it's gonna say false, right? Because int and int are not the same. So what if I were to put int and int here? Obviously that's gonna evaluate to true, because it only has one suitable overload. It's not really an overload, it's a specialization, of course, but it's going to choose this specialization over this one, because it says that is same has two of the same types. Now I'm not 100% sure if this is going to work, but let us just check it out and see what happens. Right, okay, so you don't need to have another partial specialization of is same, where T1 is a reference, so you don't have to do this, right? That would overcomplicate things and stuff like that. So, yeah, STD is same, pretty easy to understand in my opinion. So STD is same is actually used for a lot of template constructs, right? So let me just, you can create a STD floating point, right? And you can do it as follows. It's actually quite easy. So let me just write template class T and say struct is floating point, and we're gonna have a static const expr bool value, excuse me, equals is same T float value, right? So we're gonna type const expr auto value equals is floating point float value. So this is gonna print true, because it's gonna create or instantiate this struct, and it's gonna pass T along is same, and as long as T is a float, it will return true, and otherwise it will return false. So here it's true, obviously, because T is in fact a float, and a float is a floating point value or type. But if we were to enter a double here, then it will result in false, because we haven't said that double is a floating point value, right? So we're gonna say or is same T double value. So if this evaluates to false, then it still can evaluate this to true, and if this is true, then the whole expression is true, right? So this is once again going to result in true, and I will show you in a minute. Alright, so now it's gonna print true again. But what if I were to add a long double? So now it's gonna evaluate false again, and we do the same trick, namely is same t long double value. So now it's gonna print true again. So yeah, was a relative short video about how you can implement your own is-same. So yeah, SCM is very, very small, but might be a hard concept to grasp. But it's kind of funny that such a small piece of code may confuse people, but it's not really that hard, right? So I hope you've learned a lot from this video, and if you have questions, please let me know in the comments. I'd be more happy to answer them, and I'll see you next time. Bye bye.